On this episode of Design Cut Build, we're building a mailbox. It's the last episode of the season, so let's see if I learned anything. Let's get ready to design, cut, and build. Hello and welcome to the Season 3 finale of Design Cut Build. We've had so much fun building all these projects for you, and we've got one more to wrap the season. In this episode, we're building a mailbox because we love hearing from you and want you to send us your suggestions for future episodes. And Iggy said he's going to be testing me this whole project to see if I learn anything. I'm nervous already, so let's just get this over with.
To prepare for this project, I spent a little time researching the U.S. Postal Service requirements for standard curbside mailboxes. So there's a little bit more here going on than I thought. Yeah, they've got 12 pages of regulations. This is pretty darn close to a fully functional regulation mailbox. The only thing that's not regulation on here is the bottom of the mailbox is supposed to have like a corrugated metal. That way, if there's any condensation or anything, it doesn't mess up your mail. Other than that, this will be a fully functional, limited service mailbox. We'll only be receiving mail, not sending mail out. So you guys can send us stuff, but we're not gonna be sending anything back. No offense. So to start, we're gonna cut the first batch of nested parts on the 4800. Aaron, you're driving. Let's see what you can do.
So what's a feed rate override?
So that is a program feed rate override percentage. So at 200% of 100
of what you have
is
programmed
200 inches per minute.
Gotcha.
So we're gonna change it to 90% of 100 inches per minute, which equals 90 inches per minute.
Okay. I like the slide. And now run job?
Pretty much. Now we get to do something we haven't done on the show before. What I'm gonna do with this stainless is, if you've ever cut stainless, I'm sure you've cut stainless with a hand plasma cutter, right?
Yeah.
You know the edges get kind of burned and charred?
They get funky.
What's happening is the oxygen inside the air when you're cutting is oxidizing and burning out that nickel or chromium in the stainless itself.
You gotta use different gas.
Right, so we're gonna use different gas. We're gonna use nitrogen.
That's really cool, because nitrogen burns at a lower temperature, higher temperature, what?
I think it burns a little bit higher temperature, but the biggest thing is it's not letting the oxygen in the actual cut.
So it's not oxidizing metal.
Exactly.
Cutting. Cool stuff.
So from here, here's our line speed test. We're gonna wanna run way faster.
Okay.
Okay, so we're gonna actually turn that up to about 200%.
Woo, all the way. Okay.
The reason being is our feed rate on a line speed test goes from 170 down to 80, and I can almost guarantee you 80 is gonna be extremely too slow for this.
Okay.
Right? Let's see, our pierce height should still be...
Got a chart. Okay.
Pierce height's gonna be 0.14, and then our cut height is gonna be 0.08. Okay. And then change the pierce delay to 0. So just press OK. Usually, when this is thicker material, you'll be able to see a V shape. But since it's so thin, we're really just looking for kind of, so you can see how it's almost not even cutting through it at 340 inches a minute. Yeah, I think 220, because we only got one try at this.
Yep.
Game time.
All right.
So we said earlier that we had one shot at this, and we messed it up. So Iggy, what happened here?
So Aaron, what I noticed when we were cutting the stainless steel is that we were cutting too high above the material. And the reason being, when I looked at the screen, was our sample voltage was turned off. Unfortunately, the machine is only as smart as the person pushing the buttons, and that was me, and I did not check that. Somebody must have turned it off before our cut job, and we were actually cutting at a set arc voltage, which is a cut height, which was too high. Once we turned that sample voltage on, it automatically changed that to the proper voltage, and it was actually cutting at that 0.08 above the material, which then made our parts cut out correctly. Unfortunately, we didn't catch that till over halfway through. So, Aaron, that's what happened.
So we tried everything to use the stainless steel, but there was so much dross. It's such a hard metal. It'll get it off, but it's going to take so much time. So in essence, we're going to sacrifice a stainless finish for a cleaner edge.
Yep, so we're going to switch over to mild steel, some 14 gauge, and unfortunately, we're going to have to scrap this stuff.
All right.
Okay, ready? Best CAD drawing wins. Go. Let's see what you got.
So you said there's CAD training available. You know, this was a really interesting build because there's all these parameters and rules to a mailbox. I had no idea. So that was really fun to explore and learn. And working with the stainless was interesting because I didn't know you had to cut it with nitrogen, so that was fun to learn. But even though it didn't work in the end, we just went with mild steel, I didn't know most of that. It may be the last episode of the season, but it doesn't mean we stop learning.
All right. I think we're about ready to start working on the door and the roof. All right, so they should be just about like this.
Okay.
Boom, and then all we need is probably like a little boom here, boom there, boom there. We don't want to put a whole bunch of heat into it,
Right,
because
right.
we don't want to
Warp that.
warp this at all.
Okay.
The reason why we are TIG welding these and not tack welding them with a MIG welder is if you tack weld it, it's going to deposit too much metal, right? So then we'll have a bump here and it's not going to look good. So if we do it right, we can TIG weld this without affecting or having to grind any of this down.
Right, so let me grab the grinder.
Here goes nothing.
So as you know, with TIG welding, practice, practice, practice. And this season, I haven't gotten to practice at all. And, you know, it's been a bit of a challenge. So I'm really excited about this episode. Even though I got to cover it up a bit and grind it down a little bit, I'm getting to TIG weld, and that's okay by me.
I think this is the best way to practice because you get to cover it up.
You know, a few mishaps here and there,
When that stays put, you know you screwed it up.
but overall, I think it's going pretty well. Aaron and I are having a good time.
Okay, Iggy's got the finishing touches on the mailbox done. Now it's time to mount it. I had an old tire rim laying around in the shop, so we thought it might make a good base. Iggy's gonna cut out a flange with bolt holes that will line up to the rim, and then he's gonna weld some square tubing to the flange to be our pole. And while he's doing that, I'm gonna be having some fun with patina. So I had a few things to work with, mostly gold and bronze kind of flame effects. So I played with those until I kind of got the look, the modeled look that I wanted. Some really cool colors emerged, and I think it really turned out neat. All right, Iggy, I think that concludes this episode. And what an episode. We got our handy new mailbox, which means we would like to hear from you for season 4, because this was the end of season 3. That's it, 12 episodes, wrapped for the year.
Boom, we're
so
done.
Thank you for watching. Please send us your ideas. When we come back, we want to see this mailbox full of them. All right? Sound good, Iggy?
Sounds good to me.
All right, you guys, thank you for watching. So I think that concludes it, right?
Yeah, that's about it.
My gloves in the box, that's where I left them. I completely forgot. So we designed it, we cut it, and we built it. We'll see you next season.
To learn more about Lincoln Electric's line of plasma cutting tables, please visit Torchmate.com.